All right, so once we have determined when the rational expression is undefined, now we can actually start operating on the expression and working with the expression. So as we go through this chapter, we're going to talk about how to perform the 4 basic operations on rational expressions. So we'll talk about adding, subtracting, multiplying, dividing. But the first thing we want to make sure we master with the rational expressions is how we can simplify the rational expression. We'll always want to make sure our final answers are expressed in their simplest possible form. So let's talk now about simplifying rational expressions. So what we'll see in this chapter, throughout the whole chapter, is that in a certain way, we're really not going to learn anything new. We're just going to take all the skills we have from operating on fractions from 4th, 5th, 6th grade and apply those now to rational expressions. All of the rules that you learned about adding, subtracting, multiplying, dividing all work exactly the same way for rational expressions. And in fact, that's true for simplifying rational expressions as well. So if we were to just quickly look at, say, an example like 6 over 10, this is a real basic one. If I asked you to simplify this in 5th grade, you would have said, okay, well, I can see that there's a common factor of 2. And so really what's happening here is you're saying, well, 6 is equal to 2 times 3, and 10 is equal to 2 times 5. And then you'd say, okay, I see a common factor of 2 here. So if I cancel those common factors of 2, really what we're saying here is that 2 divided by 2 equals 1. And what's special about 1? That's right, it's the multiplicative identity element, which means when I multiply by 2 over 2, 3 over 5 is left alone, and the value is not changed. So that's what we mean when we cancel the 2's, is that it equals 1. Anyhow, when we find that common factor of 2, we cancel out, and we're left with the reduced simplified fraction of 3/5. So this is exactly how we're going to simplify rational expressions as well. So let's see what we actually did here. Well, we took the numerator and the denominator, both of them, and we split them up into their simplest factors. So the first thing we did was we factored. So we take the expression and we factor it. It's important that we factor completely. This is why we spent almost a week and a half, 2 weeks, factoring expressions. It's critical that you're able to factor things all the way through completely. So we'll review the factoring techniques as we need them. And then also, once we factored it, we found all the common factors in the numerator and the denominator, and canceled them. So we'll factor everything completely and then cancel. Factor everything and cancel. So we're factoring only common factors from the numerator and the denominator. So we factor the numerator and the denominator completely, then we cancel the common factors. Remember, this is why we spent time emphasizing the difference between a factor and a term. Factors are the things that are being multiplied. Terms are the things being added. So you can't cancel something that's attached to a plus sign, only things that are attached to multiplication signs. So 2 steps to simplifying a rational expression. Factor, cancel. Okay, really important. So let's look at a real basic expression of a rational expression real quick, or a real basic example. Suppose we have 2x over 6. Really basic example here. So I need to do what first? That's right, factor. I'm going to factor. I need to factor the numerator and the denominator. This one's really basic. 2x, how does that factor? Yeah, it's pretty simple. 2 times x. Over 6. 6. How does 6 factor? The only factors of 6 are 2 and 3. Well, notice there's a common factor here of 2, right? Those are both factors. You can tell because they're attached to multiplication. So I cancel the 2's, and I am left with x over 3. And that is my simplified rational expression. Really basic, really straightforward. That's a simple one, but we're going to get a little bit more complicated, of course, as we go. But the concept stays the same the whole time. Anytime I want to simplify a rational expression, there are only 2 steps. Factor it completely, then simplify. let's look at another example here. Suppose I have 3ab over a squared minus a. 2 steps to simplifying a rational expression. They are factor and cancel. So first thing I'm going to do is factor this numerator. That's pretty ho-hum. Really the only factors we have here are 3 times a times b. But notice they are all separate factors. And in the denominator, what's our first rule of factoring? Don't forget our first rule is to find the GCF. So in the denominator, I see that I have a GCF of a. If I pull that a out, it leaves a minus 1. Now I'm looking at the numerator and the denominator, and I'm saying, what are my common factors? I have a common factor of a and a, so I'll cancel those both out. And I take everything that's left, 3 times b over a minus 1, and there is my simplified rational expression. That's it. Okay. Now, you'll remember we said in the beginning that we need to make sure we always identify when an expression is undefined, right? So if we come back to this expression, it's important to notice that in the original expression, I had a factor of a and a factor of a minus 1. So what that means is, if a were equal to 0 here, my expression would be undefined. Or, if a were equal to 1 in this factor, my expression would be undefined. So when we just talk about rational expressions, we in fact actually want to exclude any values of the variable that cause the expression to be undefined. So if a were 0, this whole expression would be undefined. So in our answer, we're actually going to make a note that a cannot be equal to 0. Because 0 would cause the expression to be undefined, we just note that a is not allowed to equal 0 in our final answer. Similarly, if a were equal to 1, the whole expression would be undefined. So in our answer, we'll note that a cannot equal 1. We want to exclude any values that cause the expression to be undefined. So this is a subtlety to when we're simplifying or doing any operations on rational expressions. We need to note at the end the values that would cause the expressions to be undefined. They need to be excluded from our answer set. Right? We can't plug 0 in. Even though 0 would work in this expression, it wouldn't work in the original, so we need to make sure we exclude it all the way throughout the whole problem. Okay. That's kind of a subtlety. Right now, focus on making sure you understand this part here about simplifying it, and we can talk more about this as the unit goes on, and especially when I get back, we'll be able to hammer that down a little bit more. But just be mindful that the answer key is going to show this probably, and we'll talk about that in class a lot, that we can't have values that cause the expression to be undefined. Let's look at one more example here of simplifying rational expressions real quick. Suppose we had y minus 2 over y squared minus 5y plus 6. Okay, again, there are 2 steps to simplifying a rational expression. They are factor and then cancel. So this numerator, that one's kind of boring. That one doesn't factor at all. That's the numerator. That's all we've got. But in the denominator, we've seen this guy. We looked at it earlier in the notes here, that this would factor to y minus 2 times y minus 3. And you might see this is part of why I've been a stickler about when we ask you to factor a trinomial, that I'll correct you if you say the factors are minus 2 and minus 3. It's important that we recognize that the whole factor is y minus 2. And we see that's important right here because the next step in this process is going to be to cancel any common factors. Well, we need to see that really y minus 2 is its own factor in the numerator, being multiplied by 1, and y minus 2 is its own factor in the denominator. So we're going to cancel both of those binomials as they're each a factor. But if we look again, we see that the numerator really was y minus 2 times 1. So when we cancel the y minus 2, we're left with a 1. critical that we remember every factor when it's canceled is actually leaving behind a 1. We just don't need to write it if it's multiplied by other factors because 1 is the identity element. Like down here in the denominator, really the y minus 2 is leaving a 1 behind, but 1 times y minus 3 is just y minus 3, so we can leave our answer as y minus 3 in the denominator. So the y minus 2's cancel, and we're left with 1 over y minus 3 as our final answer, making note again of any values that would cause the expression to be undefined. We see here that y cannot equal 2, or the expression would be undefined. We see here that y cannot equal 3, or it would cause the expression to be undefined. So in our final answer, we'll note y cannot equal 2, y cannot equal 3. So this is just a quick intro to simplifying rational expressions. 2 major steps when we simplify a rational expression: factor, then cancel.